simplifying expressions. So if you recall, when we simplify, that means to write a solution in the most compact form, or in this case we're going to reduce as much as we can or combine like terms. Again, a little review. Combining like terms are terms that have the same variable raised to identical powers. All constants are like terms because they don't have a variable attached to them. But when we talk about variables raised to identical powers, we're talking about x to the third power or x to the eighth power. The power has to be the exact same number on that same variable in order to combine them. So we've got a few examples here to work through. So for example 1, when we're looking for like terms, you're first looking at the variables. So in this case, we have 5x and 4x. Since the powers, if we don't have a power, it's understood to be a 1, are both to the first power, I can combine these two. So you're going to do the actual operation with the coefficients. So I have 5 plus 4, which is going to give me 9. My variable stays the same, and I still have this constant of a -3 at the end, so I'm going to put -3. If we look at example 2, I have 4x cubed plus 3x squared minus 7 minus x squared plus 2. So I always like to start with my highest exponent, because that's how we write our answers, are with highest degree or highest exponent value first. So in this case, I have 1x cubed. So I'm just going to rewrite that term down. Now I'm going to look for x squareds. So I have a positive 3x squared and a negative x squared. Same rule applies as it does in example 1. If I don't have a coefficient or a number in front of my variable, it's understood to be a 1, so if you need to put it there, you can to help you out. So now I have positive 3 minus 1, so 3 minus 1 is going to give me a positive 2x squared. My next piece I'm going to look for are any x to the first powers. In this case, I don't have any, so the last thing I would have to do is combine my constants. Again, like we said, constants are all like terms, so we can just do their operations. So -7 plus 2 would be the same thing as saying positive 2 minus 7, so that's going to give me a -5. So this is going to be my final answer because I can't combine any other terms together. If we look at example 3, I have 10x squared plus 5x minus 3x squared minus 7x. So again, I'm going to start with my highest exponent, which is a squared. So I have the 10x squared and a minus 3x squared. Do the operation with your coefficients. 10 minus 3 is going to give me 7x squareds. And then I have a positive 5x and a negative 7x. So positive 5 minus 7 is going to give me -2, and I have a single x for my variable. So that's going to be your answer for example 3. If I look at example 4, I have 9y cubed plus 5y minus 2y squared plus 8. In this case, I'm looking at my cubes first. I only have one, so I have 9y to the third. My next highest exponent is a 2, so I'm looking at -2y squared. I don't have any other y squared, so I'm just going to copy it down as -2y squared. My next would be a single y. I only have one of those, so I have a plus 5y. And the last piece that I'm looking at is the positive 8. Again, I don't have anything else, so I'm just going to put plus 8 at the end. So in this case, example 4 is what we call simplified, because you can't do anything else to it. We can't combine any terms. We only have one of each variable. If we look at example 5, in this case you can see we have one expression and we're subtracting another expression from that. The way that I solve these is I first distribute my negative sign to each of these terms. So nothing changes with the first parenthesis, 5y minus 6. Now I have negative times a positive 4, so I'm going to get a negative 4, and a negative times a negative 7, which is going to give me a positive 7y. Now that I have that negative sign distributed, I'm going to combine my terms. So I have 5y and 7y, which is going to give me 12y. And I have these middle two constants, so negative 6 minus 4 is going to give me a negative 10. If I look at example 6, again, look for your highest exponent. So I have 4x squared and a 1x squared. So 4 and 1 is going to give me 5x squareds. If you look at the next piece, I have a negative 14x. I only have one of those, so I'm going to rewrite my negative 14x. And the last piece that I have are my xy. So as you can see here, I have an x and a y being multiplied together. This is considered like terms because they both have a single x and a single y on them. So positive 3 and positive 7 is going to give me positive 10xy. The other way that you can write this is by saying 5x squared plus 10xy minus 14x. Either of those would be correct. And the last one is example 7. Again, you have a's, so we don't always have to work with x's and y's. We can be working with any letters. If I have 4a plus 2a, that's going to give me 6a. And then I have a negative 5 and a positive 3, which is going to give me a negative 2. So the key is to look for same variables first with identical exponents, and then don't forget to use your integer rules when adding and subtracting the coefficients.